Hi, and welcome to the blog series around active-active Metro. Today we'll be continuing our brief history of Metro when we're looking at Metro architectures. So in the previous episode, we came up to the point where we have this mirrored volume, and then the mirrored volume gets stretched across the two data centers and perceived as local to any of to wherever you're looking from. So there's actually two architectural ways of solving this or building this. So the first one and the most simple one is, what if I have my data in one location on a storage array that has two controllers or two nodes? What if I took a saw to that storage array, I sawed it in half, I took one of the controllers, moved it to the other side, and then restored all of the connections I sawed through. So as you can see, it's a complex WAN setup, but now I have my controller stretched across two data centers, and this is actually the most basic form of building an active-active Metro solution. Or actually, it's more like an active-passive Metro solution, as we'll see. So we call this the uniform access method. And you may question, why is it called uniform access? Well, if I deploy the workload to one of the data centers, and let's say that workload starts talking to this controller, I now have my reads and writes going on to one controller, the writes being mirrored across the WAN, but now I decide to move my workload. So if I move my virtual machine to the other data center, now you can see that virtual machine is still accessing, of course, the same controller, right? It doesn't understand that difference. It just perceives the volume as a stretched volume, which means it will still continue to talk to the same controller. And this is a problem. As you can see, all the IOs are going through the WAN at the moment. So all reads are going through the WAN, inducing extra latency on the workload, which basically is a bad thing. Another thing is that, first of all, of course, I need to make sure that I have connectivity to the other controller. So that's part of like the complex setup you see here. But also, to consider a write. If this virtual machine performs a write, it will perform the write through the WAN to this controller. Now this controller needs to mirror that write through the WAN to that controller. This controller acknowledges the write back through the WAN, and then this controller acknowledges the written block back to the virtual machine across the WAN. So as you can see, I just traversed the WAN 4 times for a single write, which induces way more latency. Another issue here is that if I wanted to do a DA, right, moving the VM for disaster avoidance, you can see it's still talking to this controller. So I would have to manually fail that over to the other controller. That's one problem. Maybe an even bigger problem is that I have one controller on each side, which means that any controller failure will induce a failover scenario, so a failover action. So I just inserted a single point of failure in my environment, which is probably not something you'd want if you're doing Metro, right? If you're doing so much trouble to get a Metro solution, you probably don't want to introduce single points of failure. So this is uniform access. The other method goes something like this. So what if I don't take my controllers or saw my array in half and stretch the controllers, but what if I just built a controller or a pair of controllers on both data centers? So in this scenario, I have a full-blown storage array in one data center and a full-blown storage array in the other data center. Now I add some magic on top that will actually allow the mirroring or the active-active Metro to take place. So this is what we call the non-uniform access method, and it's a bit more enterprise ready, I would say. I have full-blown storage arrays, so I can lose a controller without any impact. What you also see is that the WAN setup is way less complex because all I need to do is actually mirror the writes across. There's no stretching of controllers. There's not even like a fiber channel zoning that needs to occur through the WAN or anything. Most of the stuff is kept local, all but the mirroring. Also, in modern solutions like the Power Store that we'll be looking at in this series, actually have a way of collapsing the extra functionality for the Metro inside the controllers. So that would actually, yes, it will be slightly more expensive than a uniform access method because I need 2 storage arrays instead of 1 stretched one. But you can see that there's many upshots to it, and without the need for any extra servers to actually do the metroing because it's collapsed inside the controllers, it is still pretty aggressively priced. So why is this called the non-uniform access method? Well, if I have a virtual machine that performs I/O to this controllers, and if I move the virtual machine, I can actually make the system in a way that I/O will still be local. So the locality of I/O will actually move with the workload. Yes, I still need to traverse the WAN because whenever I write the data, that obviously needs to be mirrored across. But in this scenario, a read is always local, so never traverses the WAN, which is good for low latency. And a write will only traverse the WAN 2 times at all times, right? So a virtual machine writing data here, the data needs to get mirrored. So the write is actually mirrored to this side, acknowledged back, and then acknowledged back to the virtual machine. So you always traverse the WAN just 2 times. So it is a cleaner setup. What we'll be seeing in the lab as well is that, for example, zoning is only local to the system, so there's no zoning across. You could actually do it in a non-uniform access method, but usually it adds more complexity than it solves. And yes, it does solve some complex failure scenarios in a better way, but most customers will choose to zone things only locally. So a workload will always be able to access the local array. And then if there's a failure somewhere on that level, then the upper layer, so the virtual machine layer in this example, will be smart enough to actually fail over the workload to the remaining data center. But we'll see that as we go along in the lab and do more failure scenarios there. So this is all I needed to cover in this episode. Please stay tuned for the next episode where we'll be looking at things like witness and sidedness to make a better Metro experience. Until that time, thank you for watching and bye-bye.